Kohlrausch Law. Kohlrausch Law of independent migration of ion, it states that the limiting molar conductivity, that is lambda m naught for an electrolyte, it can be represented as the sum of the individual contribution of anion and cation of the electrolyte. That means it is the limiting molar conductivity, that is represented by lambda m naught or lambda m infinity, that is the molar conductivity at infinite. That means on dilution the concentration approaches to 0, that is the limiting molar conductivity. Now the limiting molar conductivity can be represented for an electrolyte, that is the individual contribution of anion and cation. As we know that an electrolyte like NaCl is having the anion and the cation part in this way, that is Na plus and Cl minus. So this is actually the electrolyte NaCl and these are the cations and anions. So according to this law, the limiting molar conductivity of an electrolyte is the limiting molar conductivity of cation and the limiting molar conductivity of the anion, that is Cl minus. So how we can represent this by an equation, that is the lambda m naught for NaCl, that is equal to lambda m naught for Na plus and lambda m naught for Cl minus. So this is what actually the Kohlrausch law of independent migration of ions says that. So similarly we can make this lambda m naught for any electrolyte in this way. So let us tell here, as we know that the salt magnesium chloride. Magnesium chloride will give rise to magnesium ion and twice chloride ion. So how we write the lambda m value for this one? Therefore lambda m naught for this is equal to the Kohlrausch law. Similarly we can use for the example of electrolyte like magnesium chloride. As we know that the formula for magnesium chloride is MgCl2 and it ionizes into magnesium ion and twice chloride ion. So when we make the use of this law, therefore we can write in this way. So lambda m naught value for magnesium chloride is equal to lambda m naught value for magnesium ion plus lambda m naught value for the chloride ion. For the chloride ion and twice value we have to take here. So that is because 2 Cl negative ion is given here, therefore twice of lambda m naught value for the Cl negative. Now if you write for aluminium chloride, the formula is AlCl3, okay, and we have to split this one into aluminium ion plus tri-Cl negative. Now we'll be applying this the Kohlrausch law according to this. For lambda m naught value for the aluminium chloride is equal to lambda m naught for aluminium ion plus, because it giving rise to thrice chloride ion, so thrice of lambda m naught value for Cl negative. So this is the Kohlrausch law. Now let us do a text problem based on the Kohlrausch law. Example 3.7, that is a text example question. Calculate the lambda m naught for calcium chloride and magnesium sulfate from the data given in the table 3.4. Now look at the table 3.4. In that we have to find out the value of lambda m naught for the calcium ion, chloride ion, magnesium ion and sulfate ion. So let us apply the Kohlrausch law here. So according to the Kohlrausch law, what we can write for the calcium chloride? So lambda m naught for calcium chloride is equal to lambda naught for calcium ion plus twice lambda naught for chloride ion. That is limiting molar conductivity of calcium chloride is equal to limiting molar conductivity of calcium ion plus twice of limiting molar conductivity of chloride ion. Now this value, that is lambda naught for calcium ion and lambda naught for chloride ion, we can take from the table 3.4. So let us look at the table 3.4. This is the table 3.4. In that, for the calcium ion the value is given, lambda m naught value is given, and for the chloride ion the value is given. So while taking this value, we can substitute that value in that problem. So in this problem, so we will substitute the value for the lambda m naught for the calcium ion, that is this value, and twice of lambda m naught value for the chloride ion. Twice, that is important, it is twice here because calcium chloride, the formula is CaCl2. So twice chloride ions are there, so we have to multiply with 2 here. Then we make a calculation, we get the answer in this way. Next we have to find out for magnesium sulfate. Magnesium sulfate, we know that it's split into magnesium ion and sulfate ion. That means the lambda m naught value for MgSO4 is equal to lambda m naught for Mg2 plus ion and lambda m naught for a sulfate ion. Now we'll find out the values of magnesium and sulfate ion from the table 3.4. So from the table 3.4, magnesium ion, the value is given here, lambda m naught value is given, and for the sulfate ion also the value is given. So by taking this value, we'll substitute here in the problem. So we'll make a sum of this one and we get the answer, that is in the unit S centimeter square mole inverse. That is the unit for the molar conductivity, and the same will be the unit for the molar conductivity at infinite dilution. So in the examination, you might not be given that table, but the values of these values, that is lambda m naught for magnesium ion, for this value, these values will be given in the problem and you have to do a calculation in this way. So this is all about this video. Have a nice day.